Okay, so we're on 2.8. And the big deal here is that we're going to be using diagrams to factor trinomial expressions when the leading coefficient is not 1. So if you look at all the work we've done so far, it's always been x squared, not like 4x squared or 2x squared. And so if you notice here, we're getting to the point where there's 2x squareds, okay? So the idea is still the same. It's just your brain has to move to the next level of understanding, right? Okay, so Optimus Quilts sometimes gets orders for blocks that are multiples of a given block. For instance, Optima got an order for a block that was exactly twice as big as the rectangular block that has a side that is 1 inch longer than the basic size and 1 inch longer that is 3 inches longer than the basic size. So notice here, it's x plus 1 times x plus 3, but there's 2 sets of it. Do you see one set here, one set here? So there's 2 of them. Okay. So then an open version of the block is shown here with the equivalent expressions. What do you notice and what do you wonder? Okay. So there's some information here. So what do you guys notice about this right here? What do you notice about this? You've already had a chance to look at this, but anything that you notice in particular? Yeah. Very good. So notice here, I have 2 sets of x squared plus 4x plus 3. Very good. I notice the x squared is in parentheses. Very good. There's more than just one x. Good. There's a lot of set of parentheses here. So I also noticed that it's still a rectangle. And that's a huge piece because we're just still making rectangles. Very, very good. Strong work. Okay. So it says, try using some of the observations to factor each of the following expressions. So we're gonna understand this. So one of the things that you notice here, hey, look at this middle one right here. What do you notice about this middle expression right here? Anybody notice anything about that middle expression? What do you notice about that middle expression? Take your time, look at it. Move my cursor out of the way. What do you notice about this expression right here? 2x squared plus 8x plus 6. What do you notice about it? Anyone see it? Yeah, it's a rectangle. Very good. Yep, there's a 2 in front of this parentheses. But what about this one? What do you notice about each of these? Yeah. Someone said it. Yep, they're all positive and they're even. Very good. Both of you got it. Okay, so when they're all even, that means I can take a 2 out. So in my brain, I was like, oh, look, I could take a 2 out. So if I factor out a 2 there, so 2 times what gives me 2x squared? 2 times what gives me 2x squared? And someone goes, hey, Ms. Johnson, that's x squared. Very good. And 2 times what gives me 8x? 2 times what gives me 8x? Yeah, plus 4x, Miss Johnson. Very good. And 2 times what gives me 6? 2 times what? Yeah. Okay, so Miss Johnson, that's just this one. Yeah, so I'm pretending that I gave you this. What would you do next? Well, it's almost like backwards distributing. You guys all get what I'm saying when I say backwards distributing? It's like the backwards of it. Like you guys all remember how to distribute, right? Yeah. Very good. Okay, so very, very good. So one of the things that you notice is if you can look at any of these, do any of these all have the same factor in here? Do any of these have all the same factor here? Look for maybe all 2s or whatever. Do any of these A, B, C, or D all have the same factor in it? Yeah, B has what number? What does B have? All of them, all 3 of them have what? They're all what? even, right? So can you work on that one for me? Can you factor out a 2 and tell me what goes on in the inside? Factor a 2 out of that. So I'm going to pause the video and you guys factor out a 2 from this and tell me what's left over on the inside. And we'll come right back. Okay. Okay, so now that you're back, this is how you fill it in, right? You just ask yourself what's missing. So 2 times what gives me 2x squared? 2 times what gives me 2x squared? Yeah, just x squared. Very good. And then 2 times what gives me 2x? 2 times what gives me 2x? 2 times what? Yes, 1 what though? 1 x. Very good. And then 2 times what gives me -4? 2 times what gives me -4? Very good. Okay. So that's how this is what's called, what I call the GCF. Can you factor out the GCF? So can you look at this number? What number do you see that goes in all 3 of these? What number goes in to all 3 of these? Yeah. So can you, again, take a second, practice, and factor out a 3? Go ahead and factor out a 3. Okay, so I'm just going to check with you one more time to make sure that we understand how to factor. So 3 times what gives me 3x squared? 3 times what gives me 3x squared? Yeah, x squared. Good. And then 3 times what would give me 21x? Very good. Lots of people telling me. Very, very good. And then what about this one? 3 times what gives me 36? Very good. Okay, very good. So some of us, we are getting this understanding. For those of you who are not putting it in the chat, I think you're just working on it on your own slide. Very good. Okay, but you're not done factoring, because look, they have this other set that you can now factor. So if you recognize in here, some of you are like, oh, I know how to factor that already, Miss Johnson. And you're right. You already know how to factor this stuff inside, right? So because you already know how to factor this stuff inside, I'm going to let you factor that on your own, but I'm going to show you this one just to make sure you understand how to finish them. Okay, so if you were using the box method like I was earlier, or whatever case you might be using, however you think about that question that we keep asking over and over again, what times what and what plus what, is very important here. So I put the first term in the first box. That's my x squared. I'm ignoring this 2 right here. I'm just going on the inside. And I'm going to put the last box with the last term. And so that question that came up before that I kind of want to steal, I'm going to steal the question from over here, because this is so important. It's the what times what and what plus what. So I'm going to write this here. So what times what gives me -2, and what plus what gives me +1. And if you're wondering, it's these 2 numbers here, -2, +1. Okay. And so you guys are like, Ms. Johnson, it has to be 2 and 1. Very good. Right. And then, but which one would be negative? So I get a positive x. Which one has to be negative in order to get a positive x? Yeah, the 2 has to be positive. So here I'm going to put 2x, and here I'm going to put -x. And then I'm going to factor, just like I did before. I say, what's the biggest thing I could take out of x squared and 2x? X squared and 2x, what's the biggest thing I could take out of there? What's the biggest thing I could take out of x squared and 2x? Very good. Someone said x, Miss Johnson. And then it's playing what's missing. So what's missing? X times what gives me x squared. X times what gives me x squared. And someone says, X, Miss Johnson. And then I can do it again. X times what gives me 2x. Very good. Someone just gave me the first whole factor, x plus 2. Very good. And then I go x times what gives me negative x. X times what gives me negative x. X times, negative 1, right? And then you check, is 2 times negative 1, there's a negative 1 here. Is 2 times negative 1 really negative 2? And you're like, yeah, Miss Johnson. Okay, so my final answer is, in terms of this whole factoring, is 2. And then I put these 2 parentheses here from what I just got. I got x plus 2 and x minus 1. So here's my final answer. This is how I do everything. This is everything. This is the answer. I factored everything. It's completely factored. Okay. Yes, absolutely. So I factored this, I factored this, I factored this. There's no more factoring. So one of the mistakes that my students will do is they'll factor out a 2 and they'll be like, I'm done, Miss Johnson. Or they'll factor out a 2 and then they'll forget this 2 right here. And they'll just have this answer here. So quick check, because I know I did my work right, but a quick check for me, like super quick, goes like this. 2 times x gives me 2x squared. And 2 times negative 1 is negative 4. That means I didn't forget my 2, right? Very good. So I'm going to assume that you guys can all factor this. If not, we can factor that as well. But I want to go over C and D really quickly. So what number can we take out of C? What factor can we take out of C? Yeah, someone says 3, Miss Johnson. Okay, good. So very good. Go ahead and fill this in here. And so, yeah, someone says x squared, Miss Johnson, minus 9. And then I say, oh, I don't believe you. And then, so I would just check. 3 times x squared is 3x squared. 3 times negative 9. Yeah, it's negative 27. Yay, I did it. Okay. I'm going to skip to this one because I want to finish off the greatest common factor part. What's the greatest common factor? What's the biggest thing I could take out of here? Look bigger. Someone said 5, and I say yes, but look bigger. What do both of these have? Yes, very good. So I'm actually going to take a 5x out. I'm going to factor 5x out. So, okay. So can you really quickly tell me what would go in here then? 5x times what would give me 5x squared? 5x times, x. Very good. Very good. And then 5x times 2 would give me that. Perfect. And then here, I know that I'm done because that's an x and I can't break x up into any more parts. And I took out the greatest common factor. So this is done. Highlighted means I'm completely done, Miss Johnson. Okay, done. Okay. So actually, someone asked this really good question, and I got to clip it because this is a really good question. Someone says, hey, Miss Johnson, how do we know when we should use the GCF? So I'm going to tell you, that's my first step whenever I factor. This is always going to be my first step when I factor. So whenever anybody tells me to factor anything, I'm like GCF first. Why, Miss Johnson? Because I don't like all these big numbers, right? These big numbers actually are harder to deal with than this. Like look at this one. Would you rather deal with 36 or 12? And you guys are like 12, right? Would you rather deal with 27 or 9? And you're like, Miss Johnson, 27 is not that hard. But okay, but which one would you rather deal with? And the answer is 9, right? Okay, so to continue, we need to factor this one. And if you remember, this one was that special case that we dealt with, I think, last lesson. So when I do this one's going to look funny, but I'm still going to draw a box for this. Oops, this is a yellow box. I'm going to keep this as a yellow box because I started as a yellow box. Sorry. Okay. So I'm going to put x squared in for the first box and -9 in for the last box. But you guys are like, hey, Miss Johnson, there's no middle term. Yeah. What number is that? What number is no middle term? What number would that represent? Miss Johnson, there's no middle term here. What number is that? What do you guys think? If I said, hey, there's no middle term here. So this whole like what times what and what plus what, this would be -9. But the what plus what number would I put there, Miss Johnson? Okay, so let's copy this first of all. Let's put that over here. So I would put here -9. That makes sense. But here there's no term. So I would put a 0. Crazy, right? Oh, now I know how to do it, Miss Johnson. I know you guys know how to do it. So as soon as I tell you that it's just a 0, then you're like, oh, I understand what you're talking about now. Okay, so what times what gives me -9, but at the same time, what plus what gives me 0? And you're like, okay, Miss Johnson, but 9 is only 1 and 9 and 3 and 3, right? Yeah, so it's got to be the -3 and the +3x. So a -3x, +3x, and then you guys can do the rest of this, right? So go ahead and take 2 seconds to finish this off. And then we'll move on to the next little part. What would your final answer be now? What would your final answer be? So I would keep this 3 right here, right? And what would go in these parentheses? That's what I'm looking for. Because then that would be my final answer. What goes in here, guys? Okay. So let's multiply out really quick just to make sure that we're all on the same page, right? What's the biggest thing you can take out of x squared and -3x? What's the biggest thing I can take out of x squared and -3x? What do you guys say? Yeah, x. And then you'd say, okay, well, x times what gives me x squared? Good. And x times what gives me -3x? Good. And then I get x times what gives me +3x? X times what gives me +3x? Very good. I got +3. So there's my two terms, x -3, x +3. Does that make sense? Yeah, this one is confusing because it didn't have a middle term. So when it doesn't have a middle term like that, then I just turn that no middle term into a 0. Very good. So again, how would you check this answer? I would just multiply out. I can distribute here. I can use the box here. Just make sure you're checking your answer. Very good.